Didn't really get an opportunity to explain how simple this experiment was at the time I first performed it. So I think we'll look at all the apparatus and what's going on. Keep it pretty simple. We're just trying to do a simple test to measure energy. So if we were to do that, it might be worth using a couple of like controls, being a bit careful, not being too sloppy about it. So obviously if we want to find the energy of something, we could use a device or whatever you want to call it that measures energy, as we call it. Then, we need some weights that we can sort of keep at a constant, not just like glue, some bits of metal together that you found in the back of your shed or something, they are actually uniformly pretty matched weights, apart from this one having what I like to call a marker, but it is actually just a regular zip tie. Amazing what you can do with things, isn't it? So here we've got like, pretty fucking hefty base. How do I turn this cunt on? I can't see a fucking thing. Ah, there we go. Oh look, numbers. Well, no, not yet. We have to do the magic now, don't we? Make it make numbers. Ooh, what's that? 652 grams. Not that this actually really matters all that much, but for some people they might find it interesting. So it's pretty fucking heavy. It's not like half a kilo, something like that. What we got here? The rod. Ooh, what's that? 331. That's 600. Oh, so it's like what? Nearly getting towards a kilo for all that shite, yeah. So, not that that matters anyway, but there we go. We have a rod here, and at the end it's got a bit of thread. And over there we've got some washers and a nut. We've got a hole there. And we can put that in the hole and put that nut thing on there and tighten it up, and there you go. So there we go, look at that beauty. Oof. Fantastic, just bolts straight in there, and it's pretty solid. I haven't actually bothered to tighten it up because I'm not actually doing any experiments, so because I've already done loads. I'm just showing the apparatus, keeping it simple, using a few like controls, not really being like too rushed or sloppy or lazy about it. If we're trying to measure something, it just kind of logically makes sense to probably simplify it down to a basic sort of level, where you can know as many constants or have controls that you can control, even knowing the constants. So with all that, it makes sense to be a little bit, sensible and careful about it, not really all that sloppy or thoughtless. Actually, quite what some would probably suggest as a scientific approach to the thing, but there you go. Horses for courses, I suppose. Yeah, so as we said earlier, we're obviously going to have, if we're doing a an experiment, you know, where we're doing a drop test onto a spring to see how much it compresses, you know, we're going to need a spring, aren't we? So here we go, there we go, spring. And if we use the same spring, say in all the experiments with all the different weights and velocities, you know, that would probably be quite sensible, I suppose, you know, given that it's a spring and it's got a constant. Oh, another constant there. We've got another thing in the experiment that we really kind of know, so that's pretty useful. And you know what, I was just going to show you the weights, but I thought, you know what, we haven't actually measured the spring, have we? The weight of the spring. I don't think I've ever done that. That'll be exciting. Oh, it will be. Oh, don't tell me the fucking boxes have gone. Oh, twat. I'm pressing the wrong one. Hey, right, there we go. I've had it for ages, still don't know how to use it, but anyway. What was I measuring? Spring. There we go. Spring. What's it weigh? Oh, so I can balance it. Oh. I wonder if it wobbles as it got lighter. 5 grams, that looks to say. Yeah. 5 grams. Wow, amazing. Right, there we go. So yeah, here we've got the little weights that we're dropping. So we've got this here. That is actually a laboratory stand. You know what they mix sort of chemicals and shit on. All that crap. Anyway, so that's like a repurposed upright stand, which when I do it, obviously it's leveled, everything's leveled off. I'm not doing that now because I'm not doing it now, but obviously when I do it because, you know, I'm a lazy bastard, so there you go. But anyway, we have that, and that rod there is 10 millimeters. These weights that I've been using are linear bearings, like they use in CNC machining, you know, when they're fucking going back and doing all that crap and shaving, you know, creating whatever, a machine fucking part. But anyway, so they're uniform. Obviously they're pretty uniform, they're not going to be like majorly fucking different. Obviously this one with the zip tie on is a bit, but not a lot. So what we go, $25 grams. That's a single one without a zip tie. That's 24 grams. And this is 2, so 2 taped together, and that weighs 49, so they're like 28, no, 49, so, oh, it's gone to 50 now, right, 49, so they're 24 and a half, aren't they, basically, because so that's not measuring the extra half, because it's there, obviously, and that's measuring 25, so that's like potentially half a gram. Yeah, that's right, yeah, half a gram heavier, because this thing don't measure half grams because it's cheapo. So, oh, pardon me. Fuck. So basically now, if you're not completely bored out your fucking tree and you're actually still watching, yeah. So what we were doing now, we were dropping shit onto a spring, basically. So, you know, all sloppy like, you know, we're not bothering really with anything. But yeah, so we're dropping things onto a spring. We want to measure some stuff with it. So yeah, we've got the weights, haven't we now? So we know we've got these. We've got as debris to drop onto. We've got some weights. If we can do like 1 mass, 2 mass, 3 mass, and 4 mass pretty easy by just sort of attaching them together. And then also we can just, hold them. Don't bother with quick release shit because you just like, or tape measures. Don't bother with that. That to me looks about 11 centimetres, I reckon. Not sure now. But anyway. So, yeah, it seems we've got this problem now because we've got to drop as weights that we know what the weights are. We can't change them. We can only, like, multiply them. And they are constant in, they're consistent in when you do that. When you put 2 together, you get kind of 2. And when you put 3 together, you get kind of 3. And, it's all pretty good, really. All good. Consistent. So, yeah, with that all, being said that, so we've got the weights there, they're consistent. We've got the spring, that's got a constant, that's pretty consistent. Now we've got this issue of, how do we do the heights? How do we get them consistent? And then obviously this being a lab stand, it comes with like a little, I don't know what you call them, stops. Well, that's what I call it, like a physical stop. Oh, that's what it, yeah, you can put it on there, like tying it on tight so it doesn't move. At a point anywhere along it, or what, I don't know, it's probably some technical name for that, like, I don't know. But anyway, at any point on your rod, you can, vice it, get it on there, get it tightened up, and there you go. You've got like a, almost like what you could class as like putting it, fixing it in a certain position from the, well, not the ground, obviously, because we're on a table, aren't we? Actually, when you look at it, yeah, the whole apparatus is on a table. I wonder if that makes any difference. It's one to think about, isn't it? So yeah, here we go. We've got this little thing. It's like, you're gonna love this. Look at that. Lower it down, and then just lock it off, and stays there. It defies gravity. I'm not sure if I'm a bit scared now. Oh no, that's fine. That's what it's supposed to do. So yeah, there we go. How far have we come in humanity to, look at that. Not very smooth action though, is it? Could be better. Yeah, I'm not complaining around, but so yeah, with this thing we can basically tie that on to, any point on there. And then I just get a bit of tape, put that on like that against it when it's on there. I can't be arsed showing now because I haven't got fucking 3 pair of hands. You know what I'm saying? So yeah, when it's on there, that's it, tape it up, lock it on. So we have this bit. We're measuring from here. Then we can get a tape measure, which I haven't got at the moment because it's outside in the shed, and I cannot be fucking arsed to go and get it, and I'm not. But yeah, basically then put that doobie on with the bearing stuck to it, get a tape measure from the top of the spring to the bottom of the bearing the distance, and it can be whatever. Well, it can't be whatever we want to be. You know, obviously it does not go on for infinity. I'm sorry about that. It was only $6.99 off eBay. Yeah, you gotta just, beggars can't be choosers, can they, really? So there we go. We can go as high or as low as the rod will let us, let's say. And I think, yeah, roughly to get the 4:1 ratio to get twice the speed, the maximum. You know, I paid for $6.99 for this fucking rod, and I'm having every fucking penny's worth out of it. So there we go. It just worked out at 44 and 11. If I could have gone more, I would have done. But you know, in the pursuit of science and making correct measurements, if I would have, you know, to do that, say go 12, oh no, there's not enough left, or, you know what I mean? So to get the exact sort of ratios that we're all sort of agreed on and looking for, then it would make sense to, you know, do that. You know, all sloppy like. You know, I could have just guessed, I suppose. I'm not saying how close I'd have been to the same results, but I think it's probably better just, you know, like I say, using a few measuring tools for the start, you know, to actually set it up, and then have some consistencies within the experiment and keep it quite simple, you know, like just But when we're looking at, you know, like cameras and all that bullshit and frame rates, not everybody can afford all that crap. And when you really think about it, when you're dropping these things onto the spring, regardless of the masses and the velocities, there comes a point where they stop. You know, in time they actually do come to a standstill before they go back the other way. And if you can just capture that frame, which I've, you know, after multiple tries, now and again, you capture the frame, and that shows you the maximum compression, because that's the point it stood still. You know, that's why that particular frame, you know, obviously when it's going twice as fast, yeah, it's a little more fucking blurry, because it's going twice the speed, it's happening twice as fast. So yeah, so that's basically it. All the footage obviously isn't filmed on a super duper high speed fucking slow-mo camera or whatever. It's actually filmed on my phone, but like I've explained, you know, if we actually think about it, there comes a point when this drops onto the spring, it compresses the spring, and there is a point where, boom, it just stops before it goes the other way. And like I say, if you can capture that, which obviously the phone can, so we're not in need of super high-tech equipment, but, you know, it'd be nice, and it'd be better to see it that way. Agrees. But, you know, how far do you need to be sort of, I don't know, going really, when you can pretty much see what's happening. So yeah, there's my totally and utterly lazy and sloppy attempt at doing an experiment. You know, I could have just stayed in fucking bed, I suppose. So there we have it. You know, I'm dropping things onto a spring experiment. All sloppy and lazy like, you know. So yeah, in conclusion, so yeah, we've got a spring that has a constant. We have weights that have a constant. We have a, I don't know what it calls. I'll call it a stop. Call it a little vice thing, whatever. So again, we have something we can keep constant within the experiment when we're performing it. You know, we're not just going, oh yeah, fucking drop it from somewhere. We are actually thinking about what we're doing and thinking about what we're trying to measure and thinking how we could actually do that sensibly and rationally and logically. You know, or yeah, like I say, we could just go to the back of the shed and just find some offcuts and bang them together and film it and go, there you go, I've discovered, you know, new physics. Oh yeah, I thought of something else I could add as well. Obviously, these are taped together. So obviously, when I do 4, I have to tape obviously 3 lots of tape. But you know, tape them together. But when I do that as well, I also slip it inside the rod. So when I run the tape around, they're lined up perfectly. You know, there's not. You can't say when there's 4 together that they're all on the piss, you know, and all catching and creating different kinds of friction. You know, you could come up with that bullshit, I suppose, but you could. But like I say, there you go. So they're all just taped together. Obviously, ones that are on their own aren't, and this one with the one with the marker on. Yeah, so there you go. The one with the marker on is the one. So if it's a 1 mass, that'll be obviously the 1 mass. If it's a 2 mass, you know, we have the technology to tape them together, and then we can do that with that one as well. I tell you what, that obviously isn't. I haven't tightened that up because, like I say, I'm not actually bothering because I've done it all. But yeah, like magic, you know, you can take 4 together, and there you go. So we can have as controlled masses, and they're not catching because they're all, you know what I mean? Yeah, you slip them on that rod and they get them taped up firmly. There you go. Right. I was just hunting around for a pencil, and I found there. Look at that. How fucking cool is that? I think, what's that? Pink and black. Weird combination. But anyway. So, does it work? Has it run out? Yeah, it works. It hasn't run out of ink. That's great. I'm happy with that. Right. So, in this like simple sloppy experiment, because obviously we're thinking about doing an experiment, measuring something, so it'd be sensible to keep some constraints in there and keep obviously the experiment. Oh god, sorry, tired. It would be I don't know if I can see to do that, but is that showing up? Yeah, simple. Keep it as simple as possible, and then have some elements of control over it, which, you know, in this one we've got also the control of the distances or height or displacements or whatever you want to call it, units. Just, you know, we can measure it, and through that we can know the speeds because we've got the constant of gravity. And again, that's pretty consistent, I think. I don't, unless you're on the moon, maybe, I don't know, but I'm not on the moon. Well, yeah, I could be. That could be how I'm making it do all this weird shit, huh? You don't know I'm not on the moon, do you? I could be. So, yes, here we go. Simple. So we've got a spring, spring, and it's got a constant. We've got the heights that we can keep constant. We've got the force of gravity that's a constant. And then, when we know all that, we can... Oh, I don't know, is it? Well, you know what we've been talking about here. We can drop it onto a spring, the weights at the various speeds, and see how much... Oh, sorry, I am tired. Let's see how much it compresses a spring by measuring it in some way with, you know, some sort of guide as to how far, you know, something with numbers on, preferably, and increments of, you know, measurement, so you don't have to guess, really. I suppose a lot of people think that, you know, amateurs or hobbyists or whatever you want to call them, people who are interested in science and nature and what actually really does happen, you know, can't perform or think for themselves or, you know, do a reasoned way of looking at something and try and test nature itself, which, you know, no matter how you look at it, whose opinion has, you know, who has what opinion about what, nature is what it is. You can argue with it, but it doesn't change it. It doesn't change what it is. You know, if you argue an elephant's a giraffe, you know, maybe if you did it, you know, for 3 trillion years and evolution took place, I don't know, it would turn into one. But, you know, if you're saying, if you just keep saying, no, that's a giraffe when it's an elephant, it's never going to be a giraffe because it's an elephant. So, yeah, I mean, these things are testable to the hobbyist or amateurist, or, you know, like I say, or really people who are actually interested in finding out what really happens, rather than just, well, I suppose it's not so much that, it's wanting to learn and see how these things actually work and the relationships that go on and the laws of nature itself and some of the underlying characteristics of nature, rather than just going, oh, I saw a documentary and it said that, so yeah, but not really understanding it. And I'm not saying I don't think anybody can. I think it comes down to interpretation, I suppose, and some people, but at the end of the day, you can't deny what happens when you perform certain tests. You get results, and if you then say, well, that isn't what I wanted to see, because you've got a preconceived notion of something that happens, and you do that experiment again and again and again, or you do it in a different way again and again and again, and you still keep getting a result you're not expecting, then eventually you might think that that result, could actually have some validity to it. Well, for anybody who's still actually bothered to listen this far, which is probably nobody, but anyway, if you have, in conclusion, thanks for watching, and I mean that from the bottom of my heart. Thank you for watching, people. It's been interesting.